So today we are going to start with the next topic, that is lesson number 5, gravitation. And in today's lecture we will solve all the numericals that are given in the textbook. Okay, so let's start with the first question. At what distance below the surface of Earth the acceleration due to gravity decreases by 10% of its value at the surface? Now this is question based on acceleration due to gravity with the depth, and we know that the variation of gravity with depth is given by GD, that is the gravity at depth D, is given by original gravity at the surface times 1 minus d by r. This is how we give the variation of gravity with depth d. Now, if the gravity decreases by 10%, means if the original gravity is 100, it will decrease by 10%, so it will become 90. So I can treat this, if the original is 100, I can treat it in this way. Then it will become, gravity at depth d will decrease by 10%. Whenever there is question of percentage, you can treat original as 100. So if it decreases by 10%, this will become 90 times 1 minus d by r. And if you solve this now, 90 by 100 is 9 by 10 is 1 minus d by r. So solving this, d by r will be 1 by 10, that is 1 minus 9 by 10. And as we know that radius of Earth is 6400 kilometers, on cross multiplying, the depth will be r by 10, that is equal to 640 kilometers, because the radius of Earth is 6400 kilometers. Okay, so the next question is question number 2. If the Earth were made of wood, the mass of wooden Earth would have been 10% of the present value. Then calculate the escape speed from that wooden Earth. So if the Earth is made up of wood, then in that case, if its mass is 10%, what will be the escape velocity? Right now we know that escape velocity from Earth, the formula is under root 2gm over r, and the value present, it is 11.2 kilometers per hour. Sorry, per second, 11.2 kilometers per second. This is the present escape velocity from the Earth. But if the Earth ka mass would have been 10%, if it was made up of wood, in that case, everything would remain same. 2 is constant, g is constant, size is not mentioned, it remains same. Only the mass becomes 10%, means the mass becomes 10%, means it becomes 1/10. Then what will happen to escape velocity? So clearly escape velocity is proportional to the mass ka square root. And if mass becomes 1/10, the escape velocity becomes 1 upon root 10 times the value, that is present value, 11.2. And now you have to solve this. If you solve this, it becomes 11.2 divided by root 10, which comes out to be 3.18, and on dividing this, it will be roughly 3.5 or 3.6 something kilometers per second. So this is the value of escape velocity of that wooden Earth. This is approximate value, you can calculate using log tables. The next question is question number 3. Calculate kinetic energy, potential energy, total energy and binding energy of artificial satellite of mass 2000 kg orbiting at height of 3600 kilometers. So if this is Earth of radius r, and if a satellite is revolving at height h from the Earth's surface, this is satellite, let us say, if it is orbiting, then the energies associated with satellite can be given by the formula, let us say kinetic energy. The formula of kinetic energy is gmm over 2r. Okay, and for the relation between the energies, kinetic, potential, total and binding for orbiting satellite, you must remember this relation. In the case of satellite, the energies, kinetic, potential, total and binding, are related in this way. Kinetic is always equal to binding for a revolving satellite. It is always equal to total, but with a negative sign, means total is already negative. If you put a negative, it becomes positive. And potential energy is twice, so make it half, and it is also negative, so to make it positive, there is a minus sign. This is the relation between the four energies. So let us calculate one. Easily you can find the remaining. So what is kinetic energy? The kinetic energy will be G, the value of G is given, 6.67 times 10 to the power minus 11, but 6.67 I will write it as 20 by 3. Kinetic energy is 6.67, that is 20 by 3 times 10 to the power minus 11 into the mass of Earth is given 6 into 10 raised to 24 into the mass of satellite is given 2000 kg divided by the distance r is basically r plus h. So 6400 is the radius and 3600 is the height. So it becomes effectively 10,000 kilometers. But kilometers into meters in SI unit will be into 10 raised to 3 further. The 2 is left, I'll multiply it with 2 as well. So this 3 and this 2 will make it 6, which will cancel with this 6. So now what is left is 20 into 2 is 40. 20 into 2 is 40, and only the powers of 10 are left. See, these are 3 zeros which will cancel with this 10 raised to 3. 1, 2, 3, 4 will straight away cancel with 24 and become 20. And this is 10 raised to 20 and this is 10 raised to minus 11. So effectively what is left is 10 raised to 9 joule, because it is energy. So kinetic energy is 40 times 10 to the power 9 joule. And since we have calculated kinetic and we know the relation between all the energies, this is only and only valid for orbiting satellites, not for those satellites which are at rest on Earth. Only valid for orbiting satellites. So what will be binding? The same answer for binding, 40 times 10 to the power 9. What will be total? The same answer with negative sign obviously. And for this is total. And for potential, the energy should be made double because the 2 will get multiplied and double with a negative sign. Minus 80 times 10 to the power 9 joule. These are the energies of satellite orbiting at height 3600 kilometers. So this is the answer for question number 3. The next question is question number 4. Two satellites A and B are revolving around the planet. The periods are 1 hour and 8 hours respectively. The radius of orbit of planet B is given 4 into 10 raised to 4 kilometers. Then what will be the radius of planet A? The orbit of planet A is asked. Now we know that if the satellite A is revolving in this orbit such that its radius is RA and satellite B is revolving around the planet with radius RB, then their periods, that the time taken to complete one revolution, the periods is dependent on the radius and it is given by Kepler's laws. The third law states that the square of time periods is proportional to the cube of their radii, the radius of the orbits. So this question is based on Kepler's third law, and the question is what will be the radius of orbit of the planet A. So if I use this proportionality, I'll get TA, that is time period of planet A, upon time period of planet B, the whole square, is equal to, because since I'm taking the ratio, proportionality sign will go, radius of orbit A upon radius of orbit B, the whole cube. And the ratio, I can put the values. First planet is time period is 1 hour, the second one is 8. So 1 by 8, the whole square, R will cancel, is RA upon RB. The second one is 4 times 10 to the power 4 kilometers. This is cube. And the square of 1 by 8 is 1 by 64, is RA upon 4 times 10 to the power 3, 10 to the power 4 kilometers, the whole cube. And if I take the cube root on both sides, the cube root of 1 by 64 is 1 by 4, and therefore 1 by 4 is RA by RB, and RB, that is already given, that is 4 times 10 to the power 4 kilometers. So on solving this, radius of orbit of the first satellite is 10 raised to 4 kilometers. Okay, so the next question is question number 5. Very simple question. Gravitational force between Earth and Sun is asked. Straightforward formula, that is Newton's law of gravitation. The formula is F is equal to G, mass of first object, that is Sun over here, mass of Earth upon distance square. All the data is given. I'll put the values. Gravitational constant is 6.67, which we consider as 20 by 3. because even 20 by 3 is 6.67 times 10 to the power minus 11 into mass of sun, mass of earth. If I multiply 2 into 6 times 10 to the power 30 and 24 is 54 divided by the square of this distance. Now the square of this will become 2.25 times 10 to the power 22, right? So 3 and this will cancel, so it will become 2 and now 20 into 2 into 2 is 80 into 10 raised to 54 minus 11 is 43 divided by 2.25 into 10 raised to 22, and 10 raised to 43 upon 10 raised to 22 is 10 raised to 21. And what is 80 by 2.25? 2.25 I will write it as 9 by 4. If you divide 9 by 4 you get 2.25, so this 4 will go up. If 4 goes up it becomes 320 by 9 times 10 to the power 21, and now I can easily divide this 9 के table में 3s are 27, 5 is left, so 5s are 45, 5s are 45, again 5 is left, and 5 6 into 10 raised to 21. Since we have calculated force, the unit will be Newton. So this is the force of attraction between the sun and the earth. And remember, this force is exerted by sun on earth, as well as this force is exerted by earth on sun. This is the force is exerted on both the bodies, sun as well as earth, and the force is equal. Okay, so the next question is question number 6. Calculate acceleration due to gravity at height 300 kilometers above the earth's surface. So the variation of gravity with height, GH, the formula is, actual formula is the original gravity times R upon R plus H the whole square. This is the correct formula for calculating the height at, the gravity at height H. But there is one more formula which is the approximate version of this formula, and it is only made because if the height given is very small as compared to R, we can use that approximate version. Because in this version the problem is you have to use this square, you have to square the terms. So using this formula is slightly difficult. So when the height above the earth's surface is very small, up to, let us say, up to 500 or 600 kilometers, 600 kilometers tak, you can use this variation of this formula, and that variation is G1 minus 2H by R. We have proved this in the derivation, that this is equal to this during the theory. So if I use this, because height, since it is given 300, which is very less as compared to the actual value of Earth's radius, I will use this formula. So the value of G is 9.8. I'll consider it as 10. Approximately we will calculate. 1 minus, what is 2H? 2H will be 600 upon R is 6400. Since units are same, they will cancel out. Kilometers in numerator, kilometer in denominator. 2 zeros will cancel. 64, 6. So this is 3, this is 32. On cross multiplying, 32 minus 3 is 29 upon 32 into 10. So the answer comes out to be 290 by 32. So on solving this, you will get answer roughly 8.88 meters per second square. After solving this, you get the answer 8.88 meters per second square. This is acceleration due to gravity at height 300 kilometers above the Earth's surface. So the next question is, calculate the speed of satellite in orbit at height 1000 kilometers above the Earth's surface. So the question is to calculate the critical speed, and the formula of critical speed is under root gm by small r. This is small r is the radius of the orbit. Means if this is Earth and the radius is r, if the satellite is revolving at height h, then this h plus r is equal to small r. So we will put the values. The value of gravitational constant 6.67, which we put 20 by 3 into 10 raised to minus 11. The mass of Earth is 6 times 10 to the power 24 divided by r plus h. It is 6400 is r plus h is 1000. So on addition it becomes 7400, but it is in kilometers. So into 10 raised to 3. Okay, so 1 0 will cancel over here, 1 0 will cancel, 3 2s are, and 2 into 2 is 4 upon 740 inside the square root. 10 raised to minus 11 and 10 raised to 24 will give you 10 raised to 13, and 10 raised to 13 upon 10 raised to 3, this is 10 raised to 13 upon 10 raised to 3 will give you 10 raised to 10 into 10 raised to 10. Okay, so the perfect squares can be taken out. 4 is a perfect square, so its root is 2. इसका root है 10 raised to 5. लेकिन इसका root क्या है? What is the root of this? The closest roots that we know is 23. What is square of 23? It is 729. So ये 729 से थोड़ा बड़ा है, 740 है. So let us consider it as 23.1, 23.2 approximately consider कर लेंगे. Okay, so 2 upon 23.2 into 10 raised to 5. So if you want to solve this, दो zero इसको देंगे तो it is 2200 into 10 raised to 3 divided by 23.2 meters per second, and on solving this properly, the answer that you will get is 7.3 into 10 raised to 3 meters per second, which is equal to 7.3 kilometers per second. This is the velocity of the satellite. You have to use log tables. Question number 8. Calculate acceleration due to gravity on Mars if the radius and the mass of Mars is given. So for any planet, the acceleration due to gravity on surface is given by formula gm by r square. And as mass and radius of Mars is given, you have to simply put the data and get the answer. The value of g is 6.67 universal gravitational constant, which we take 20 by 3 times 10 to the power minus 11 into the mass of Mars is 6.4 into 10 raised to 23 divided by the radius of Mars is 3.4, and you have to square it. 3.4 into 3.4 is 16, 13, ये हो जाएगा 12, 10, 6, 5, 1, 1. It is 11.56 into 10 raised to, ये 3 है, किलो का 3 है, so ये 10 raised to 6 है, उसका square 10 raised to 12, right? Okay, so 20 into 6.4 upon 3 into 11.56 into all the powers. ये है 23, ये है minus 11. So 23 minus 11 is 12, and ये 12 will cancel. So all the powers will cancel. यहाँ कुछ नहीं बचेगा. This is acceleration due to gravity. Now on solving this, इसको solve करना है. This will become 20 into 64, 6.4. If I give the 0 to this, it will become 64. 64 into 2 by 3 is 128 by 3 into 1, 11.56. Okay. So 128 by 3 into 11.56. 3 into 11.56, if you multiply 3 into 11 is 33, or 3 into 0.5 is 1.5, so it comes out to be 34.5, और ऊपर है 128, and on dividing this, log of 128 minus log of 34.5 and taking anti-log, you will get the answer as 3.7 meters per second square. This is acceleration due to gravity on Mars. So next question is question number 9. A planet of mass 6.4 10 raised to 24 kg and radius 3.4 10 raised to 6 meters. Calculate energy required to remove 800 kg object to infinity from that planet. So basically the binding energy of that object is asked. From any planet, if you want to remove any object of mass m to infinity, you have to provide it binding energy on the surface. And the formula of binding energy on surface is gmm by r. And this energy should be given to this 800 kg object so that it will escape to infinity. So, what is the value of g? 20 by 3, 10 raised to minus 11. The mass of the planet is 6.4, 10 raised to 24. And the mass of that object is 800 divided by radius is 3.4 into 10 raised to 6 kilometers, so 10 raised to 3. So this 10 raised to 3 will cancel with 1, 2 and 3 zeros. This 10 raised to minus 11 and this is 10 raised to 24 will be 10 raised to 13, and this 6 will cancel with it, so 10 raised to 7 is left. So now we'll see the numbers. 2 by 3 into 6.4 into 8, 6.4 into 8 upon 3.4, right? So 3.4 into 3 will be 10.2 and 6.4 into 8 is 51.2 into 2 into the power of 10 raised to 7 is left. And what is 51 twos are? Is 102.4 upon 10.2. Clearly this is stanza. So 10 into 10 raised to 7, that is 10 raised to 8 joule. This is the binding energy, and this much energy will be required to take this object from the surface of this planet to infinity. So the answer for question number 9 is 10 raised to 8 joule. So the next question is the 10th one. Calculate capital G. Even though we know the value of G, but in this question we have to calculate its value if mass, radius and acceleration due to gravity is given. So the formula that we know, the relation between these four is acceleration due to gravity is Gm by r square. And since we want to calculate value of G, I will isolate the term. So G will be equal to gr square by m. And if I put the values now, 9.8 SI unit, radius is 6400, we have to square it. 6400 into 6400 into kilometers is 10 raised to 6 divided by mass is 6 into 10 raised to 24. So 1, 2, 3, 4 and this 6 is 10 raised to 10 will cancel with this and become 10 raised to 14, because these two and these two are 10 raised to 4 and this is 10 raised to 6, so that is effectively 10 raised to 10, and this 10 raised to 10 with 10 raised to 24 will cancel and 10 raised to 14 is left. Now in numerator, 64 into 64 is 4096 into 9.8, roughly if I treat it as 10 upon 6 into 10 raised to minus 14, as this 14 will go up, it will become 40960. But since it is actually 9.8, इसको थोड़ा बढ़ा दिया, 10 कर दिया है, so I will just drop this extra part because इसको बढ़ाया तो इसको कम करेंगे. I'll make it 4000. So 4000 into 10 is 40,000 by 6 into 10 raised to minus 14, and 6 के टेबल में 6 is 36, 4 is left, 6 is 36, sorry 6 is 36, 6666.6 into 10 raised to minus 14, and if you shift 1, 2 and 3 zeros, this will become 10 raised to minus 11. So the answer comes out to be 6.667 because it was recurring into 10 raised to minus 11, and we know the value of G is exactly the same. So this is the answer for question number 10. So next question is question number 11. A body weighs 5.6 kg weight on Earth. How much will it weigh on a planet whose mass is 7 times of Earth? Now I have made a small correction. In the textbook it is given 1/7, which is not correct to get the answer right. So actually there is a misprint. It should be 7 times the mass of Earth and radius is twice. What will be the weight on that planet? Now we know that weight basically depends on gravitational acceleration. So I can say the weight ratio, the ratio on that planet, the weight on that planet upon weight on Earth will be equal to gravity on that planet upon gravitational acceleration on Earth. But acceleration due to gravity is Gm by r square. So using this formula, the weight will be proportional to gravitational acceleration, which is proportional to mass. So it will be proportional to mass of that planet upon mass of Earth into, it is inversely proportional to r squared. So into radius of Earth upon radius of that planet का square, it is inverse proportion. So P will be down, Earth radius will be up. In this question it is given the mass of that planet is 7 times that of Earth. So 7 times ME, and radius of that planet is twice that of Earth. Twice that of Earth. Radius of Earth के twice the radius of planet is, उसका square है. So this will cancel. So 7/4 will be the ratio of weight on that planet, which we don't know, upon weight on Earth, which is 5.6. And if you cross multiply, you will get weight on the planet as 5.6 into 7/4, and 4 14s are, that is 4 into 1.4, it is 4 14s are 56, so 4 into 1.4, and 1.4 into 7 is 9.8. So weight on that planet will be 9.8 kg weight. This is the answer for question number 11. Last question is question number 12. What is the gravitational potential due to Earth at point which is at height 2 RE above the Earth's surface? RE is the radius of Earth. See, the question is, what is gravitational potential at distance 2 RE, at height 2 RE from Earth's surface? So from center the distance will be 3 RE. And we know that gravitational potential because of Earth at distance r from the center is given by minus gm by r. This is the formula of gravitational potential. Minus gm by r. So in this, minus g is 20/3 into 10 raised to minus 11. This is 6.67 10 raised to minus 11. I am taking it as 20/3 into the mass of Earth is, we know the mass of Earth is 6 times 10 to the power 24 upon r is actually 3 radius. 2 RE is the height plus RE. So it is 3 times the radius, that is 6,400 kilometers. So 10 raised to 3. So this 3 will cancel with this 6. It will become 2. So ये हो जाएगा 40 into minus 11 plus 24 is 10 raised to 13 divided by 3 into ये 64 है, 64 1 2 zeros, and this 10 raised to 3 will become 10 raised to 5. So 10 raised to 5, 10 raised to 13, फिर क्या बचेगा 10 raised to 8, correct? 10 raised to 8. And now 40 by 64, 4 10s are 4 16s are, so it becomes 10 by 3 16s are 48 into 10 raised to 8. In order to make numerator greater, I will write it in this way: 100 into 10 raised to 7, एक zero इसको shift किया, upon 48. Roughly if I treat it as 50, so clearly it is 2s are, so the answer is 2 point something into 10 raised to 7. See, there is a minus sign everywhere, so I will continue with that sign. So the potential is negative, and gravitational potential ka unit is work done per unit mass, joule per kg. So the answer is 2 roughly into 10 raised to 7 joule per kg. This is the answer for question number